Hello, 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 everybody, and welcome back. Hope you're all doing well, and hope you're all as eager as I am to start question number 19 on our Pascal paper. An integer is defined to be upright if the sum of the first two digits is equal to its third digit. For example, 145 is upright because the first two digits, 1 and 4, add up to the third digit, 5. How many positive three-digit integers are upright? Okay, so we're specifically talking about three-digit numbers. So I might say, well, a sort of generic-looking three-digit number looks like A, B, C. If it's three-digit, then really the only thing we can say at this point is A isn't 0. We can definitely say that for certain. Now, if it's upright, we'll need to have A plus B is C. So this strikes me as sort of a counting problem, and there are plenty of ways you could go about counting this up. You could start by saying, okay, let's assume A is 1. What sort of values for B and C could we have? And, you can do 1 plus 0 is 1, so 101 is an upright number, and you can go 1 plus 3, I'm skipping a few, and you get 4. You can do things like 1 plus 9, but then that would mean C is 10. So, that's a problem. And there's no reason you can't do this. You could also do the same thing focusing on B. I'm going to focus on C. What can C be? Now, why am I focusing on C? It's not that doing the A or the B way is wrong. And indeed, you don't have to focus on particular integers. You might try and do something else. But I think it's going to be easy to break it down into cases and say, what if C were this? What if C were 10? Or not 10. What if C were 9? What if it were 8? And so on like that. And the reason I'm focusing on C is C has to be a positive integer. It's got to be a single digit. And, A and B have to be single digits as well. But if I fix C, I sort of then have to say, well, what A's and B's can I have? And that's going to be a little nicer, a little cleaner, because if I start fixing my A's and say, well, what B's can I have to then check, do they add up to C, but is C double digits? And I think it's going to be a little extra work. Just a little extra work. And so that's why I'm going to focus on C's. I'm going to say, all right, instead of focusing on A, let's focus on C. What if C were 0? Well, A has to be at least 1, so you're going to get 1 plus something is 0? No, that can't happen. What if C were 1? A has to be at least 1. Okay, and then 1 plus, well, what B values could I have? 1 plus 0 is 1. Could A be something larger? And as I do this, I'm actually now realizing it would probably be easier to count down from 9. So instead, I'm going to start this way. Let's see. B9. So now I need A and B. They need to be single digits. A has to be not 0. But could A be 9? Yeah, you could have 9 plus 0. Or you could have 8 plus 1. Or 7 plus 2. Really, we can have just about any combination. We'll write them all out right now. 2 and 7. 1 and 8. The only thing I can't have is 0 and 9. So of the 10 different ways I can write out C being 9, only one of them, the one that starts with 0, doesn't count. So there's 9 ways to do this. What if C were 8? So if C is 8, I need A plus B to be equal to 8. My first two digits have to be equal the third. And so that could be 8 plus 0. I mean, that's as big as A can possibly be. It's contributing everything. B is contributing nothing. 7 plus 1. We could have 6 plus 2. 5 plus 3. 4 plus 4. So this would be 448. That's an upright number. 2 and 6. 1 and 7. And then 0 and 8. Those are the ways to write 8 as a sum of two single digits. And only the last one wouldn't count, because that would be 088. That's not a three-digit number. That's 88. That's a two-digit number. So how many do we have here? We count them. 1, 2, 3, 4, 5, 6, 7, all up to 8. 8 ways. And we start to notice a pattern. Indeed, for whatever value C I choose, A plus B can be C plus 0 or C minus 1 plus 1, all the way down to 1 plus C minus 1. And then the other possibility, of course, is 0 plus C, but that wouldn't be a 3-digit number. So there's C ways to do this. So in total, how many upright numbers are there that end in a 9? There's 9 of them. How many that end in an 8? There's 8 of them. End in a 7, a 6, a 5, a 4, a 3, a 2, a 1. None of them will end in a 0. And we already had sort of confirmed that when I tried to start off by saying, what if C were 0? Okay? You could even list them all out, but of course this isn't a written question. You don't have to write these all out. As soon as you recognize patterns, can extend those patterns and convince yourself that those are the correct patterns, you just need to start adding them up. So 9 plus 8 plus all the way down to 1, we just need to add that up. It turns out that's 45. You can add that up manually. This might be something that you recognize. These are called triangular numbers. So a really fast way, just as a little aside, if I want to add up the first n numbers, 1 plus 2 plus 3 plus all the way up to 9, it's n times n plus 1 all over 2. So in this case, it would be 9 times 9 plus 1, 9 times 10 over 2. 90 divided by 2 is indeed 45. So I'm going to look for an answer of 45. And if I don't see it, it might mean that my reasoning, my patterns are off. Okay? But just because I see a 45 doesn't mean that I was necessarily right. But I have confidence in my patterns here. And so there we go. There's D, 45. And we're all set. So that was what? Question number 19. I will see you guys for question 20 in the next video. Until then, take care.